All right, problem number 3. Sum of integers from -10 to 50. If I wrote this in like interval notation, like it's not really interval notation, but let's just pretend it was. We are including these numbers. It would look like this. If I was writing this range, it would look like this. So since we are including these numbers, guys, it goes from -10 through 0 through 50. And we include this, and we include this. So when we are talking about series and sequences, if I give you a range of numbers, you can subtract them, but you always add 1 because we're including this value. So the total number of integers from -10 to 50 is 61. If I wrote out -10, -9, -8, -7, all the way up to 50, I would have a total of 61 numbers that I have written down. Are there any questions on that? It's because we include this. We include what we're at. Okay, then let's go ahead and move forward. Sum. Ooh, I get to write that fun looking sigma thing. That means sum. So we are finding the sum, and remember n is -10, and we're going to stop at 50, and that's going to be a total of 61 numbers. Now remember that sigma notation. Let's go ahead and talk about partial sum. So partial sum, remember, is the formula in red. Remember, there's a total of 61 terms. Once you write that subscript, you go write that in the numerator. It's always the same. And remember, it is the first term of -10 plus the last term of 50. Um, 122. Did you guys get this? I don't have a calculator, so I need y'all's help. Any questions? Y'all got that? Everybody got that? That's the right answer. That's the partial sum. Okay, so with that being said, let's go ahead and look at this notation here. We're going to find the partial sum from 1 to 100. There are going to be a total of 100 numbers here. So we are going to take S of 100 equals 100 divided by 2. And then my first number, guys, is going to be subbing in the number 1 right there. When we sub in the number 1 right there, 2 times 1 is 2. That's A sub 1. A sub 100 is going to be 100 times 2. So it's just 200. So it's going to be 50 times 202, and 50 times 202 is going to be 10,100, I think. I don't know. Please do that on your calculator. What's 50 times 202? Is that right? Thank you, Maria. Okay. Any questions on number 4? And you know what? Number 5 looks just like number 4, so I'm going to ask you to do that on your own. 51. It doesn't start up in number 1. So again, guys, 51 up to 100, we're including those values. Now, if I did 100 minus 51, I would get 49. So after 51, it would be 49 numbers to 100, but we're including 51. So our total numbers is 50 because we're including 51. And guys, if that doesn't make sense, on these partials, when it doesn't start at 1, just remember to find the total. It's big minus little plus 1. If you just want to remember that formula, just remember that formula. So 49 plus 1, and remember, we're adding plus 1 because we're including the 51. Okay, so now that I've told you the total, it's going to be a partial sum of 50 terms. What's a sub 1? What's that? Yes, yes, yes. Good job. Y'all are right. How'd they get that? They did 51 times 7. Remember, you take these numbers and you just multiply them. What's going to be the last number? I could do that one in my head, but you tell me. What is it? 700, yes. All right, y'all. On your calculator, multiply those out and make sure you get 26,425. Please, please make sure you get that. Okay, so now I really am going to take roll, and then we're going to come back together for problem 6. While I'm taking roll, listen. Please find the partial sum for this one, then find the partial sum for that one, and then subtract them. And guys, the answer to this problem is 2,500. See if you can get that without me. I've just done several problems with you guys. See if you can run with that. So the answer to problem 6 is 2,500.